I hope this screen is visible.
Yeah.
Okay, fine. So hello, welcome everybody. Today we are going to discuss a few conceptual questions and on very specific base topics. So for fluid mechanics, so we are having a PYQ bootcamp session. So these are the topics we had requested our students about which topics they would have they would like for us to discuss. So we are going to have 50 questions we will discuss. If not today, we'll split this video into two halves, and we'll have the second half of the session in the next week, because we will make sure that you understand first. The completion is not important as much as it is important for you to help you revise first. So we'll discuss hydrostatics, fluid kinematics, fluid dynamics, potential flows, boundary layer theory, drag and lift, and in under momentum equation we'll include RTT, linear momentum, as well as angular momentum questions. All right. So with the first question, I'll ask Pranay to take over and start with our sessions.
Sure.
Yeah, Pranay, please share the screen.
Is it visible?
Yeah, it's visible.
Okay, so starting with the first question. This question is from hydrostatic forces. So first of all, you guys can try for 3 minutes. That's the time in gate exam. You will get 3 minutes. Okay, you guys can try. Yeah. Hello. Isha, is there any way we can fix a timer or something? I will check with-
Sir.
Okay. Isha, just click on the apps sidewise in your title bar. Click on app. Can you find timers there?
It's loading. Timer.
Loading, sir.
Click on timer.
Okay.
But for that, you have to make your camera off from the laptop device. Okay. And your.
There is no such option, sir.
Okay, I'll do it. No issue.
It's okay. I'll start with 3 minutes.
No issues. I'll put it.
3 minutes time. Huh? Try this one.
2 minutes 30 seconds left. Okay. Is it visible to you guys? The timer.
Yes, sir.
Is it
Hello, am I audible? Hello. Hello.
Yeah. Hello. Yes, you're audible. The timer is off.
Timer is visible or not?
Guys, somebody can please respond if the timer is visible or not. Okay, it's visible, huh? Fine.
Actually, I can't see it, but I don't know about others.
I think on AceScape Education top, you'll find it.
Okay, how many of you got the answer? Anybody tried? How many of you got the answer? Anyone? Hello. भाई कोई respond भी कर दो. Hello.
Please respond, guys.
Anyone? Hello.
Check the chat box. Okay, Isha. They are replying in the chat.
Okay. Okay, fine.
So you need some
No,
more
sir,
time,
trying.
or I
No,
will,
sir, not.
or I should.
They're trying, I think. Give them some more
They're trying.
time.
Yeah.
Mhm.
Take a minute more. Okay, I think I should. Where they are coming from. Okay. So in the question, what they're asking is, in a dam with a curved shape is shown in the figure. The cross-sectional area of the dam shaded portion is 100 meters square, and its centroid is at x equals to 10 meter. The vertical component of hydrostatic force Fz is acting at a distance xp. The value of xp is. तो ये क्वेश्चन हाइड्रोस्टैटिक फोर्स का पर थोड़ा अलग है. 2014 में आया था गेट में. तो जिसने जिसने ट्राई किया, क्या मुझे बोल सकते हैं कि मतलब अप्रोच क्या था, कैसे ट्राई किया आप लोगों ने कुछ? एनीवन? कोई एक माइक ऑन करके बता दो भाई, कैसे ट्राई किया था. हेलो.
Isha, check the chat box.
रिस्पॉन्ड कर दो यार कोई.
There are no responses at the chat box as of now.
ट्राई किया भी किसी ने? अच्छा, वेट. Okay, so I will solve. So they have said that this shaded portion is 100 meters square. So I'm taking this as A1. Let's say A1 is 100 meters square. So now you can see, if I draw a straight line from here and a straight line from here, what I can see a rectangle, right? This is given 40, this is given 15. So what will be the area? Hello, anyone? Hello. What will be the area? भाई कोई रिस्पॉन्स भी कर दो यार. तो इसके guys, then I will try to solve. और भाई रिस्पॉन्स करना करके, ठीक है? कैसे किया, फिर कुछ किया या नहीं किया, तब भी करना. And yes, if anybody is interested to know that how this XP, I am writing this XP as a centroid. Okay, I will put it in the group. That will be good, I guess. If you are interested, okay, then send a message in the group. I will send. Now try this one. हेलो सर, तो वो टाइमर मिल सकता है क्या? हेलो हेलो हेलो, am I audible? हेलो.
You are actually.
Wait, I'll share the timer.
अब तो हो गया शायद, 1.5 मिनट तो हो ही गया होगा.
Pranay,
Yes sir.
just say you are only, you only get time with you, and just that will be fine, okay, for them.
Okay, then I will. Yeah.
Don't wait
fine,
for
fine,
that.
fine.
Just think like you are directly going on YouTube. I don't think so anyone will reply. So just give 2 minutes max. If not, then you just go on with the solutions, all three of you. Okay.
Okay sir. Wait just a minute guys then. ट्राई किया किसी ने? Anybody has tried? तो चैट बॉक्स में लिख दो किसी ने ट्राई किया. सर ट्राइंग.
सर ट्राइंग लिखा है.
ओके चलो क्वेश्चन पढ़ते हैं एक बार. Consider a lawn sprinkler with horizontal arms of radius A is equals to 10 centimeter, which has water introduced vertically through the center as shown in the figure. The exit area of the jet is 25 centimeters square and the jet velocity is 1 meter per second. The water is ejected orthogonal to the sprinkler arm and the jet makes an angle 60 degrees with the horizontal plane. Find the torque required to hold the sprinkler stationary. Consider water density as 1000 kg per meter cube. Neglect the effects of friction and gravity. तो ट्राइंग कौन लिख रहा था? अच्छा हाँ, कोई बताएगा कि तुम बताओगे कैसे ट्राई कर रहे थे?
Guys, please speak up here. Like chat is fine, but you have to like talk to the mentors also, no?
बताओ यार, कुछ प्रॉब्लम हो रहा है, कहाँ पे हो रहा है ये बता दो.
कैसे अप्रोच करो एटलीस्ट वो तुम बताओ सर को.
एंगुलर मोमेंटम इक्वेशन वो तो ठीक है, वो तो दिख रहा है. मैं पूछ रहा हूँ कि ट्राई कैसे किया, शुरू कैसे किया, ये तो बताओ. ओके वेट. अर्नब, हेलो अर्नब, हेलो.
Arnab Das, can you please respond?
Okay. So guys, we are considering. Okay. Yeah. So we are taking anti-clockwise as positive, clockwise as negative, anti-clockwise as positive. ये पहला कंसिडरेशन है, इसको देखना, ये इंपॉर्टेंट है क्योंकि इस पे हमारा साइन डिपेंड कर रहा है, एंटी क्लॉकवाइज को क्या लेता है, क्लॉकवाइज को क्या लेता है, ठीक है। नाउ इफ आई सी प्रॉपर्ली, यहाँ पे ना एक पिवोट होता है एयर, तो वाटर यहाँ से आता है, फिर यहाँ तक जाता है और यहाँ से निकलता है, यही है। दिस इज हाउ अ स्प्रिंकलर वर्क्स। नाउ लेट्स से द एंगुलर मोमेंटम इक्वेशन, किसी ने कहा ना एंगुलर मोमेंटम इक्वेशन, क्या प्रॉब्लम है? Tau is equals to MVLRL final for left arm plus MVRRR final for right arm. Okay, why I'm not writing initial? Because the initial velocity is 0. There is only the final velocity. There is no initial velocity, there is only final velocity. Okay, now अब देखना है साइन, साइन के बारे में थोड़ा बात करते हैं। Look at the face, it is like this, it is like this only. So the water that is coming out from here, it will try to rotate it in which direction? Anyone? In which direction? The water that is coming out from this arm, it will try to rotate the sprinkler in which direction? In this direction. Okay, so I have taken it as positive. Another face is here like this only. It will try to rotate in this direction. All right, so दोनों ही एंटी क्लॉकवाइज हुआ, that's why I'm taking both as positive. Now तो ये भी पॉजिटिव है, ये भी पॉजिटिव है। नाउ द थिंग इज, अब मैं लिख सकता हूं ना 2 into m dot v r। ऐसा क्यों लिखा? बिकॉज आर्म्स लेंथ आर सेम, द वेलोसिटी इज सेम, सो इन दोनों को मैं अगर प्लस करूं तो यही आएगा ना, सेम है। नाउ अब बात है, हेलो,
Yeah, you're audible.
actually I have some issue with my PC. Okay, hold on a second. Yeah, you move to the next question. Okay, I will come back to this again. I have
Okay,
some
fine.
issue with the
Roshan.
PC.
Okay. Then Roshan, you take over.
You unshare the screen then.
Wait.
Guys, can you see the screen?
Yes, Roshan, your screen is visible.
Okay. So this question is from the fluid dynamics. So before I give you the answers, please tell in the chat box what could be the answer. You guys must know this answer. This is a very basic question.
I think I've launched the poll. Yes. So answer in the poll, guys.
Okay. Answer in the poll then.
Only one person has responded to.
Come on, guys, it's the basic question.
Three. There are 1, 2, 3, 4, 5, 6 participants, student participants.
So till now we got the 4 answers, right?
4 answers.
What
yes.
about you two guys? Come on.
Slide shares? This slide is Roshan put it in the slideshow mode.
Okay. Is it fine now?
Still not there in slideshow mode yet. Only 4 people. Okay, we'll end. Since you others are not responding, we'll end it. Yeah, I've shared the results.
Is it now in the slide mode?
This is in slideshow mode.
So for 4 of them have answered, right? Okay.
Yeah.
So I'll ask the person who have given the answer B. Like, why have you thought the answer could be B? So here it is saying now that which of the following velocity profiles typically represent a fully developed incompressible turbulent flow in a pipe. So see, we know that for laminar flow, what is the velocity profile? For laminar, we know that it is a parabolic profile, right? And for turbulent, it is logarithmic. So from here we see that this, like we have seen that this profile is known as the parabolic, and the turbulent one, it is a little bit flattened than the laminar. So from that we can say that the profile for turbulent will be this C. Also, there is one more relation that we can use here, if you know, like for that U max upon U average, that is equals to 2 for laminar, right? But for parabolic, what it is, the ratio is equals to 1.1 to around 1.15. So we see that the maximum is very close to this average velocity in case of turbulent. But for laminar, what we see that the maximum is twice than the average velocity. So we can see here that the average will be around right here. So it is very close to the maximum value. But in this case, the second one, which is like twice, average will be around this, and we get that like the option B is for laminar case, and the option C is for turbulent. So from this also we can get the solution. So I hope you understood this. Now moving on to the next question. First, you guys try. This is a very good question. You guys try and put the answer.
One person has responded so far.
At least how many of you are trying?
Two people have responded.
Okay. Do you want more time? You guys can even like say the approach if you like think that it will take more time to solve. So you guys can say me the approach.
Somebody wrote they're still trying. Okay. So 4 people have responded, huh? I think the results are visible.
Yeah, actually 2 of them got the right answer, but 2 of them are wrong. Okay, then at least any of you guys like who have given the answer A, can you tell me how did you get that? Like what is the approach behind that? At least talk, yeah. Like if you won't talk, you won't get 100% like benefit of this. Chatting is fine, but you guys need to talk, yeah. Anindya, what's your approach? You can share.
He
Okay,
has
fine.
written in that box that it is we tried with the principle of orifice.
Oh,
but
yes. Okay, I see. Anyway, let's move on to the solution now. So see, this is a very good question. Why I'm saying that? Because normally what we do is we apply Bernoulli equation in this type of question and we get the answer. But here one thing is that due to this hump, what happened that the level of this water surface has decreased. And now that the distance from this hump is h1, the surface, the level of the surface is now h1 from this hump. So what we'll do here, let me show you. So because of this hump, what happened? The surface got reduced. The height of this hump is h, right? And this is h1. And earlier the height was h. So when we when we apply, let's say this is 0.1 and this is our 0.2. And in the question, what is it? It is asking that, sorry. Let that go. In the question, it is asking that horizontal, the discharge per unit width is. So we need to find out the discharge per unit width. So we know that the discharge is given by area into velocity, right? And the area can be written into height into width, and it is velocity. So here what we're getting is that discharge per unit width is nothing but height into velocity. Fine. Now in point 1 and 2, when we apply the continuity equation, since the width is constant, so we can write that h into v1 that equals to h1 into v2. Here this is the point 1, this is point 1 and this is point 2. So from here we get a relation like v1 upon V2 is nothing but H1 upon H. Fine. Now, when we apply Bernoulli here, like we have to, since we don't know the pressure difference between point 1 and point 2, okay. So for that purpose, we need to apply the Bernoulli on the surfaces. Like if we apply the Bernoulli on this point and this point, what we can say is here the pressure is P1 by rho g plus V1 square by 2g plus the elevation of this point from, let us say this is the reference hour. So the elevation is height h, and that is nothing equal but P2 square by P2 by 2g plus V2 square by 2g, P2 by rho g, V2 square by 2g plus what is the height of this point from the datum that we have assumed? It is nothing but h1 plus h, right? This is the h1 point and the hump's height is small h. So we can say it is nothing but capital H1 plus small h. And since the surface is free to the atmosphere, we can say that P1 is equals to P2 and that is equals to P atmosphere because it is free to the surface. Like it is open to the atmosphere. So from there we can cancel these two. And here we get the expression like V1 square minus V2 square by 2g. I should add V2 square minus V1 square by 2g, that is equals to capital H minus capital H1 plus H, right? So we have this equation. And from this equation, what we can do, we can substitute any of the velocity in the terms of other. So let us put that. We can say that V2 is nothing but HV1 upon H1, right? So let us put that HV1 upon H1 minus V1. This is the whole square upon V1 square divided by 2g, that is equals to h minus h1 minus h. Therefore, if we take the V1 out, V1 square common, this is h upon h1 whole square minus 1, that is equals to, we are crossing this over there. It is 2g into h minus h1 minus h. So from here, if we see that the value of V1, what we are getting is, V1 is nothing but 2g into h minus h1 minus h upon h1 whole square minus 1 root over of this, right? So we got the velocity at point V1. So we got the velocity at point 1. Now if we multiply by the height, because we are calculating the area discharge per unit width. So we need to multiply it by h. So when we multiply it by h, what we'll get? We will get Q upon W, that is equals to h into V1. So when we are multiplying it with h, 2g h minus h1 minus h upon, and we are taking here, see, this is h upon h1 whole square. So we are taking common this h square term, like we are taking it outside the square root. So what we are left with, we can multiply here h by h, right? So if we take h square by h square, let's say. So if we take the h square common, what we'll get? Outside will get an h, and here will be left by 1 upon h1 square, excuse me. Let me write it here. So Q by W, we get that HV1, right? And it is equals to H, and outside we get an H because we have taken the H outside the square root. So inside the square root, what we are getting? 2g h minus h1 minus h over 1 upon h1 square minus 1 upon h square. So this is cancel. So we got the answer. This is basically the answer, option number 1 here. Where did that go? Excuse me. So this is the right answer then. I hope you guys understood it. If you have any doubt, like you can say right now. Like, did you get the? Did you understand the solution? Respond in the chat. No problem. Okay then. So the main concept was that we have to apply the Bernoulli equation on the surface because we don't know the pressure difference between this point P. Like if you are taking at any other point inside the let's say water, so we don't know the pressure difference in that. So with the help of like on the surface, we know that the pressure is equal to atmospheric pressure. So from there we got this answer. Like that is the main concept here. So let's move on to the next question. I'll stop sharing my screen.
This is the question here, and first tell me, are you guys going to try this or should I start solving only? First, you give me the answer because then we will not waste time much. Is the screen visible?
Yes, it is visible.
Okay, fine. Anybody, please write it in the chat box. That would also be fine. Are you trying? Or if anybody knows the approach, they can tell me. If not, I'll just quickly go through because none of you seem interested. Okay, fine, try. Okay, try. There are, okay, one thing. This is ux plus 2. This is m by 2 pi into ln of root over x square plus y square. I'll write it here for you. Phi is equal to ux plus m by 2 pi ln of root over x square plus y square. This is the reciprocal potential function here. Screen not visible, is it?
Screen, yeah, actually it is not visible right now.
Yeah, from my side it is not visible.
I asked you people. Now? Is it visible now?
Actually, no.
Hello?
No.
Still not.
Still not visible. th- Now tell me.
Now it is not.
Yeah, it is visible now.
Okay, fine. So anybody got the answer? should I proceed with the answer? Guys? Anybody answered in the poll? Can anybody tell me? Roshan or Pranay? Hello? Okay, then if nobody is going to respond, I will proceed to solve the question. So, have you all seen the lectures I have taken on this potential flows? Because if you have, then this is like 30-second question. Have you? I think in my lecture, I have discussed that this is my R, this is my H, and the value for R is given by anybody? No one. Okay,
Respond
fine.
कर दो यार, या फिर मैं ही respond करूंगा.
Let it be. M by 2 U naught, it is given by R is given by M pi by 2 U naught, and H is given by pi M by U naught, right? These are all have been discussed in the lectures. I have shown how to come to that, come to these conclusions also. I will not waste time by giving you that kind of huge solutions. If you want, you can go back and look at the lectures. I'll just give you how to proceed from after knowing this from here, how you will proceed. So this is, first of all, you have to identify what kind of flow is this. You can do two things. Either, first of all, they have given you the diagram only. So from diagram only, you can identify that this is Rankine half body, right? Rankine half body. And even if the diagram was not given, you see, okay, it is here only. So I'll not write again. This equation is essentially, this is uniform flow, and this is basically my, anybody? Can you write in the chat box? It's source flow, right? Okay, so source flow plus uniform flow makes Rankine half body. So you will identify it from that, from this velocity potential function equation as well. You can identify. The only difference is here, our source will become, it was just M. Here it is M by 2 pi. So in here, we have to multiply it by 1 by 2 pi. So our R will become M pi by 2 U naught into 1 by 2 pi. R is this distance. This is coming as M pi cancel by 4 U naught. They have asked A dash. So this distance as well as this distance. By using symmetry, we can multiply it by 2. So our A dash will come as 2 into M by 4 U naught. So M by 2 U naught. U naught or U? Here it is U, right? So D. U naught was the notation I used in our lectures. That's why I was mentioning that. Is this fine? Is this clear? I'll move on to the next question. No response is coming. I'm really not feeling like. If you want, I'll just give you quickly one refresher about the potential flows. For uniform flow, the phi is given by U naught x. Or if you go to the polar coordinates, then U naught r cos theta. Cos. And psi is given by U naught y, U naught r sin theta. This is for uniform flow. For source and sink flow, it is given by your phi is given by m ln r in polar coordinates, or it is given by half of m ln x square plus y square. And for sink, for your psi will be given by minus of, only m of theta, which is also given by m of tan inverse of y by x. And in case of, this is for uniform flow. This is for source flow. For sink flow, it is exactly opposite. So it will become minus m ln r minus of m theta. Fine. For my free vortex flow, for free vortex flow, the velocity potential function is given by k theta, where m and k, m here is the source strength, and k here is our vortex strength. and my psi is given by my K of LNR plus some constant. In case of forced vortex, the phi does not exist, and our psi is given by r square omega by 2 plus some constant. Fine. This is a quick refresher. Somebody wrote something in the chat. Okay. I'll move ahead to the next question. Drag and lift topic. I think there will be a poll. Roshan, Pranay, somebody can release the poll. I'm unable to access it because I'm sharing the screen right now. Okay. Okay, the last ones. Okay, fine. I'll go to the next, this one. Ma'am, please explain drag and lift concept. Okay. Fine. Hold on. I'll end the poll first. Let it be. Okay. So drag and lift basic concept, I'll just quickly tell you what is drag force, what is lift force, how it occurs. That is all I'll in gist as I will give you, because time we don't have much. So basically, let's say we have a body here, right? And there is some fluid flowing, let's say with some uniform velocity u. Fine. So as it will approach this body, this fluid particles, it will start having some interaction with the surface of the body, right? And it will exert a certain force on the surface of the body, and this force will behave differently in different directions. Okay, if I'm saying this fluid is exerting let me take it like this. This is my body. The fluid here is coming, and it will, this force that is being applied on this particular layer of the body, it will have two different directions. One will be on the horizontal or in the direction of the motion of the fluid, and the other, this one basically, and the other one will be perpendicular, right? So it will be the perpendicular force in the direction of the motion of the fluid. This force which is acting on the direction of the motion is known as the drag force. And this force which is acting perpendicularly, it is known as the lift force. Fine. And the total force will be essentially the resultant, Fr here. So Fr will be my resultant force, which you can write as plus FL square. Fine. Now, this total force will be inclined to the direction of the motion only. Okay, whatever the motion of the fluid, it will be inclined towards that only. So essentially, the component of total force in the direction of the motion will be given as drag force, and it will be, this force is exerted by the fluid in the direction of the motion, whereas lift is a component of the total force in the direction perpendicular to the direction of the motion, and it is known as this force is exerted by the fluid perpendicular to the motion, right? I'll not go into the details of when it occurs or how it occurs, but I will tell you one thing. If the fluid is assumed to be ideal and the body is symmetrical, like a sphere or some cylinder, understand, if the fluid is identical and, oh, sorry, not identical, I mean ideal, sorry. The fluid is ideal and the body is symmetrical. then both the drag and lift forces will be 0. Okay. In such special scenarios, FD equal to FL equal to 0, which I think has been discussed during potential flows in your circular cylinder without rotation. There, I think we have discussed, I remember I have discussed this concept in my lectures. So if you have not remembered, you can go and check it out once. Okay, now, usually the drag and lift forces are given to the arbitrary shaped bodies for real fluids for some uniform velocity u, and there has to be the horizontal direction of the force. I will not go into the details of how to derive the equations for the drag and lift forces, but I'll give you the final equations. So drag force FD is given by, I think you have seen this, CD, which is the coefficient of drag into area. Area is the area of the body, which is the projected area of the body. Okay. Projected area of the body in the direction of flow. Say this is my body, whatever the projection will come here, it may be a rectangle, it may be a square circle, that projected area only we have to take, not the whole surface area. Fine. Projected area into rho of the density of the fluid into u square by 2. This u is my uniform velocity which the fluid is flowing. This is the equation for drag force. The equation for lift force is very similar. It is just here the CD is replaced by CL, which is the coefficient of lift, and the rest of it is same. Okay. Fine, guys. Okay, ma'am. Cool. Another thing I'll tell you about, since we are in this topic only, two things are there we will come across, which is one is streamline body and bluff body. A streamline body, we have streamline and bluff body. Okay. Streamline body is defined as a body whose surface coincides with the streamline. And if I'm placing my body in the flow in some kind of fluid, and this body is a streamline body, then the surface of the body will coincide with the streamline, and separation of flow will take place only at the trailing edge or the rearmost part. See, streamlines, I think you've heard, no? Like aeroplanes and fishes, they all are streamlines. These kind of bodies are streamlines. What happens is we are having the flow here. This, the fluid, when it's flowing, it will go across the edge of the body and it will only separate at the trailing or the end like this. Okay, I'll give you proper clear pictures in the group later if possible. I can't draw it here nicely. This is my streamline body. Okay. And the bluff body is something where you will have some wake formation at the end. The total drag on the streamline body will be only because of friction. Okay, shear forces only. Streamline S, you can remember shear force. Bluff body, let's say some sort of like this, some body is here. My fluid is flowing here. It will touch the surface, then it will separate, and here you will find some gap like a location, you can say, or a portion of the flow will be gap. This is known as wake formation. Bluff bodies a bluff body will be defined as the body whose surface will not coincide, right? You see, this is my body, its surface is not coinciding, it is separating, right? It will not coincide with the streamline when it is placed in the flow, and the flow is separated from the surface of the body much ahead of its trailing edge. Even though it is trailing at this point, it will start separating ahead only, and very unlike the streamline body. With this wake formation is happening. It is happening because the separation is occurring at a very beginning of the flow. Okay. I think as of now, this much would be enough for the required questions that we will be discussing. further questions you have, you can ask. Is this much fine? Did you guys understand this part? Drag and lift concepts? Somebody respond?
They are responding.
Okay, fine. So I'll come back to this question. Consider an incompressible laminar flow past a circular cylinder of diameter d. The flow is uniform at the far upstream, which one of the following figures represents the velocity profile just downstream of the cylinder. This is my body. Your flow is happening. You have to tell me how will the velocity occur across this surface, across the upside and below the surface. Will there be separation, or will there be a retardation of the velocity? Okay, I think there in option 1, the answer is not there. In option 1, the answer is like this. The velocity profile is given like this. Fine, okay. Nobody responding? All right, see, when the fluid will hit the surface of this circle, this fluid will hit the surface, no? There will be, the velocity will be reduced because of reversal. There will be reversal, the velocity will be reduced, a low pressure gradient, low pressure zone, you can say, will be formed. Okay, so what happens is it is going like this, and then it is going to reduce and across the surface. And then after the surface has left, it will start increasing again. So which one do you think is having that? Option C, right? It is increasing, then it is going back, and then it is again increasing when it has the surface is left, right? Yes, C, correct, Shubham. Okay, so that is how you should analyze these diagrams. You should look at what they have asked and think of how or what are the ways my particular flow is going to affect the whatever profile has been given or some property has been given. Okay, fine. Now I'll stop sharing and I'll hand over to Pranay. Please take care.
I think Pranay is unavailable right now.
No. Okay. Okay, I can share.
Okay.
Yeah. Is it visible now?
Yes, it is visible.
Yes, screen is visible, but PowerPoint is not visible.
Yeah. Sorry guys, there is some issue. I'm really very sorry.
Yeah, now it is visible.
Visible, huh?
It's visible.
Yeah. I think we were in this question, left, right. This question, we were in this question.
Yeah.
So I've told that okay. I think there is some problem. Now it's good. Yeah. Okay, Roshan, I think you should continue. I have some problem, I guess.
Okay, no problem. I will continue. Is this screen visible?
Yes, Roshan, it's visible.
Okay, so we have seen this question. Now moving on to the next question of dynamic. So this is the boundary layer theory question. It is also a basic question, but in this there are multiple. This is a multiple select question, so there are more than one correct answer in this question. So you guys please give me the answer of this question. Isha, you can create the poll if you want. Slide number. Since it is a multiple select question, so you give answer in the chat box only. You just leave the poll. You guys want more time? Should I begin the solution? Okay. So Dinesh has given this answer C and D, and Shubham has given the only C answer. So the correct answer for this is actually C and D both. Why it is, I'll tell you right. See, actually the question is asking that identify the configuration in which study two-dimensional internal flow may show boundary layer separation if the flow direction is left to right. So the flow is flowing from left to right, okay? So here it is flowing from in this direction, left to right. Now we know that the boundary layer separation occurs when the pressure gradient is positive, okay? So if the del P by del X is positive, in that case, the flow separation takes place, right? This is the condition to check the flow separation. So if we see in the option number 1, what is happening that it is a converging section, right? So in converging section, what happens? That the velocity will increase and pressure will drop. We know that the continuity says that like the cross section here, it is decreasing. So if we move from left to right, the velocity will increase, and since the velocity is increasing, the pressure, there will be a drop in the pressure. So here if you will see the del P by del X, it will becomes around negative, right? In the option number B, what is happening is the area is constant, so velocity will be constant. So here the del P by del X will remain like constant. If there is, we are neglecting the internal losses that can occur, the frictional losses that can occur. So here del P by del X, you can say it is not changing with X, so it is zero here. But in the option number C, what we are saying is that the cross section is diverging. So what will happen that if we move from left to right, the velocity will decrease. Why? Because the cross-sectional area is increasing, and due to the decrease in velocity, the pressure is increased, right? Here the velocity is equals like constant, and pressure is also constant. Here what was happening? The velocity was increasing, and due to that the pressure was decreasing. But in this case, the velocity is decreasing and pressure is increasing. So the del P by del X in this part will be positive. So this, in this case, there can be a flow separation. And in the option number D also, what we see that the cross sectional is drastically changing. So in this case, it is confirmed like for sure the boundary layer separation will be there. But for in this case, in option number C, it may separate. It depends upon the like the length and the magnitude in the decrease magnitude of the increase in the pressure. The del P by del X, its magnitude can decide that the flow may like separate or not. But for in option number D, it is for sure. So when if you are taking if you are saying that in what the case internal flow may show boundary layer separation, so in C also it can show the separation, and D it will show for sure. So this was the basic concept that we have to follow, that the del P by del X, it should be positive, and whatever the case is, we can select from the options. So this was a basic question. I hope you understood. Okay, then we are moving to the next question. So this is also a question of dynamics. It is a we have heard the concept of the siphon tube. So let us proceed. Like you guys give it a try, or you can say me the approach if you want. It will basically save your time. But if you want to try and give it a try and like get the answers, you can put it in the chat. We will wait for 2 to 3 minutes. Okay. Sure, try. I am waiting for 2 or 3 minutes. Okay. So I have like got one answer. Anyone else? Are you guys trying, or should I continue the answer? Okay, Dinesh have given the answer. Yeah, we will see the solution just right now. Anyone else? Okay. So before I start the solution, just give me the concept of siphon. What do you know about like siphon tube? What is the basic concept of the siphon? You can put it in the chat. No problem. What is the basic concept of siphon? Velocity remain constant. Okay, this is one characteristics of the siphon. Another, which is more relevant. Anyone? Okay, we will see. So see, Nandya said that the velocity remains constant in the siphon tube, right? Why it is so? Because the diameter of the siphon tube is constant throughout. So from continuity, we can say that the velocity is constant in the pipe, right? This is one property. And the another, like the main, one of the main characteristic that it is used for is that at the highest point, what is the highest point here? This is C, like it is the highest point here. So at the highest point, the pressure, it is the minimum in the whole system. Like the minimum pressure that we can get in a siphon tube is at the highest point, which is at the C. So here what the now let us read the question. A siphon is used to drain out water from a tank as shown in the figure. What can be the maximum height Z of the point C considered acceleration due to gravity to be 10 meter per second square? Pressure at point A is 101 kilopascal. So pressure at 1, which is PA, is given 101 kilopascal. And the vapor pressure of water is 29.5 kilopascal. So we have like vapor pressure of water. Okay. So it is 29.5 kilopascal. So neglecting friction. So can we say like what will happen if the pressure, minimum pressure goes below the vapor pressure? What happens? If pressure at any point, it gets below the vapor pressure of the fluid there, what happens? What is the phenomena that occurs? Water starts to boil, right? And that phenomena is known as cavitation. So cavitation starts to occur because a boiling point is a function of pressure and temperature both. So if we decrease the pressure, so their boiling point changes. So if we go below the vapor pressure of water, like vapor pressure of the fluid, it starts to boil. So to avoid that boiling, what should be that the minimum pressure, a minimum pressure in the siphon tube, it should be equal to the vapor pressure of the fluid, right? Vapor pressure of fluid. And vapor pressure of fluid is given. And we know that the characteristics of the siphon tube is that the at highest point, which is at C, it should be minimum pressure. So pressure at C, it is equal to minimum pressure, and that is equal to vapor pressure of the fluid, and which is nothing but 29.5 kilopascal. So this is the concept. Now we will just apply a Bernoulli equation and we'll get the answer. So applying the Bernoulli equation between point C and point A, what we can write is PA by rho G plus VA square by 2G plus datum we are considering A only is equals to PC by rho G plus VC square by 2G plus what is the height from A to C? Let us say it is ZC. Okay, we are denoting it by ZC. So we know that the VA is equals to VC because it is a siphon tube and the cross-sectional area is same. So that's cancelling this both term. What we get that PA minus PC by rho G, that is nothing equal to ZC, and ZC is what? This height AC, right? ZC is nothing but height AC, and we can write the AC as Z plus AB, and AB is given as 2 meter. So you can say that it is nothing but Z plus 2 meter, right? And we putting the value of PA and PC 101 minus 29.5 This is kilopascal. One density of water is given 1000 and gravity value is also given 10. That is equals to Z plus 2. When we solve this, we'll get the value of Z equals to 5.115 meters. Okay. This was a basic application of Bernoulli, but the main concept we need to understand is that the minimum pressure should we will get at the point C, and in this case it will be equal to vapor pressure, just to avoid the phenomena which is cavitation, and it is defined as like when P minimum is less than the vapor pressure of the fluid. So water starts to boil. And when these bubble, when this bubble collapse, it erodes the surface. So this is a phenomena that we actually try to avoid. So this is the solution for this question, 5.15. You guys understood? If you have any doubt, you can say in the chat. Okay, then we'll move to the next question. Like, Isha will continue, I guess. Isha, are you there?
Pranay, I
Hello?
think Pranay, will you?
Okay.
मैं एक बार try कर लेता हूँ last बार. Okay.
Okay, I'll
Okay,
stop
yeah.
it.
Please.
Oh. Okay. Give me a minute, okay? Visible, no? I guess.
Yeah, it's visible.
हाँ, इस क्वेश्चन पे थे ना हम. Sorry guys, प्रॉब्लम हो गया. हाँ, तो इसमें मैं डिस्कशन कर रहा था कि जो टॉर्क होता है that is equals to mass flow rate into velocity into the arm plus mass flow rate velocity right arm. I have said that this this is same, right? Here it is plus because the anti-clockwise direction, and for the same for the other side. So now we can write 2 m dot v into r. Now 2, what is m dot? Rho a v, and this v. Now the problem is, see, here they have said it is creating an angle, right? It is creating an angle that is 60 degree. So v cos 60 degree. This v is v cos 60 degree into r into v cos 60 degree. Now, given information, we can see that they have said jet area is 25 centimeter square, A is 10 centimeter. This is 1 meter, right? We can write 2 into 10 to power 3. A they have given 25 centimeter square, so 25 into 10 power minus 4. Velocity they have given 1. R they have given, I guess, 10 centimeters, so it is 0.1 meter. Now cos theta, cos 60 degree, we all know. From here, what we are getting is, you guys calculate and tell me the answer. What is the answer you are getting? -4, this is 3, 10, 2, 25, 50, 5, half, 0.1. I think it's around 0.5 by 2, 0.25. Yeah. You guys are getting this answer? Can you please एक बार कैलकुलेट करके बताओ, यही आ रहा है आंसर? Okay, this is the answer. 2 decimal places, so 0.25 is the answer. Should write the unit. That is meter. Okay. So I think what is the next problem? This one. Okay. This one is a question of last year. You guys first try for 2 minutes, then I will. Okay. You guys got the answer? Just write in the chat box. हेलो, are you guys trying? किसी ने ट्राई किया कि मतलब किस कॉन्सेप्ट से होगा या फिर कुछ? Anybody? Okay. Okay, I think I should move. This is a question based on linear momentum equation. So what is in the question? Consider a cart of mass 10 kg. They have given us the mass kg. Now it's placed on an inclined plane that is making a 60-degree angle with the horizontal. As shown in the figure, a turning vane of negligible weight is mounted on the cart. A horizontal steady water jet is issued from a stationary nozzle of area 0.1 meter square and strikes. Okay, they have given us the area 0.1 meter square, and what they have given the density 10.3 kg per meter cube. Okay, and G is given. All right. Let me write the equation first. What is the equation for linear momentum? Applying linear momentum equation is total force in x direction is momentum rate of change of momentum, final in x direction minus rate of change of momentum, initial in x direction. So because problem mein jo the main point is you have to decide the direction properly. If I take this direction as x and this direction as y, it will be a bit difficult, I guess. जब मैंने solve किया था, I got a bit difficulty in solving. So what you should do is, what I think you should go for this direction as x and this direction as y. Okay. तो फिर क्या होगा? Like this is the mass. For this liquid jet is entering from here, and what it is trying to do is it is stopping the mass from falling down. इसी को ही balance करना है बस. Just you have to balance this. So how you will balance this? Let's say this is mass mg. So definitely in this direction it will be mg sine theta. But it is in negative x direction, so I have to use negative sign. Now I got the force that is mg sine theta. यार ये थीटा को क्या हो गया? Sine theta. Now mass flow rate into velocity. Mass flow rate is same. Now the final velocity, I can see it is moving from this direction to this direction. This is the final velocity of the liquid jet. So this is v, that is minus v in negative x direction. So minus v, and this, the initial velocity is v cos theta. Okay. Now this is rho a v into, okay, I can take this v common also, can write it here. It's like this, cos theta. Now what I can do is just put the, I'm going to the next page. अब जो given था वो put करते हैं, mg sin theta लिखा था ना, so it will be minus 10 दिया था, g is 10 and sine 60 degree. अब rho a p v square minus 1 minus cos 60 degree. तो यहाँ से क्या लिख सकते हैं? 100 into root 3 by 2. यहाँ पे होगा negative. This is or 3. It is 0.1 velocity. अच्छा, velocity I have to calculate now. P. This is cos 60 degrees 1 by 2 minus 1 by 2. I guess this is minus 3 by 2. Now minus minus is getting cancelled. What is the v square I'm getting? I'm getting v square as 2 is getting cancelled. This 310. What I'm getting is root 3 by 3 here, 0.1 into 10, right? So what is the v? Tell me the answer. Anyone? You guys can write the answer in the chat box. Just calculate this. I'm also calculating. What is the answer you are getting? I think v square is 0.57735 and v is 0.7598, like this. 1.31. Okay. Check your calculation once. Let me check mine. There is 10 left. 2 is getting cancelled. 3 root 3 by 3 by this is right. 3 root divided by 3. 0.1 10. I think this is the answer, no? 0.75. You guys are getting 0.75. Check your calculation once. What is the answer you are getting? Check your calculation. I think this will be the answer. कोई एक चैट बॉक्स में लिख दो क्या आंसर आ रहा है सेम. Are you getting the same answer? Hello. Yeah. Okay. Everyone. सबका सेम आ रहा है ना? Okay. So moving to the next problem. Okay, I guess this is a 2021 problem. Yeah. Okay, try this problem. This problem I don't think it will take more than 1.5 minutes. Try. देखो सेम कंसेप्ट है, ठीक है. लीनियर मोमेंटम का कंसेप्ट है, सेम कंसेप्ट है. कुछ नहीं करना है, जो फोर्स नीचे लग रहा है उसके साथ जो फाइनल मोमेंटम और इनिशियल मोमेंटम उसको इक्वल करना है और कुछ नहीं करना है. ट्राई करो. ट्राई. हेलो. Anybody has tried? Hello, am I audible?
Yeah, you
Am I
are.
audible?
Yeah, you are.
कोई कमेंट कर दो यार, कुछ लिख दो चैट बॉक्स में. ट्राई किया या फिर आई शुड. Okay, let us read the question. A spherical ball is steadily supported against gravity by an upward air jet as shown in the figure. Take the acceleration due to gravity. G is given. The mass flow rate of air. Mass flow rate of air is given. Mass flow rate of jet is given. That is 0.01 kg per second. G is given and they have given us the velocity. Okay, you are getting the answer. भाई ग्राम में बोला है ना. हाँ, they are getting the answer. Okay. That's fine. This is 3 meter per second. तो लोगों मैं एक बार just you are getting the answer. That is good. So this is what you have done. I guess you have balanced this one, right? Like this. If I'm doing wrong, tell me. They have given the mass flow rate of jet. So rho AV is given 0.01. velocity is 3. What will be m? 0.03. 0.003. It will be 3 gram. इसका आंसर है 3 ग्राम. दोनों का आया. That is good. So what I've done is I've done nothing. Look, ये जो ball है ये नीचे आ रहा है. So they have told us to calculate the mass. Okay, and the air jet is flowing like this. It is stopping the ball, the spherical ball. So what you have to do is just the same thing. Just use the same equation. Mass flow rate into velocity final in x direction minus mass flow rate into velocity initial in x direction. अब देखो initial velocity is there, but there is no final velocity in not in x direction. This is a bit wrong. This is in y direction, right? If I consider this as x direction and this is y direction, then I can write it's y. There is an initial velocity in a y direction, but there is no final velocity in this direction. So what I have done is I have taken mass flow rate as common, final minus initial. This mass flow rate is rho av, and this initial velocity is there, but this is 0. That's where I have got this rho av square, what I have written here. Okay, solve तो कर लिया होगा तो समझ में तो आ ही गया होगा. That is good. I guess ये वाला problem, right? Okay, try this problem. ये भी same ही है, linear momentum का ही है, same है, same concept, same formula. Try this question. Anybody has tried? Try किया किसी ने? Hello? Hello? Oh, you got the answer? Yes. What is Shubham? Shubham, you have tried now. So did you got any answer or just you are trying? भाई कुछ एक्स्ट्रा नहीं है ना, सेम सेम कंसेप्ट है, कुछ अलग नहीं करना है। जो लास्ट वाला कंसेप्ट था, सेम कंसेप्ट ओनली। Okay, I think I should. So what they have given in the question is water enters steadily into a horizontal pipe bend, which is part of a larger piping system. As shown in the figure, the volumetric flow rate of water is 0.1 meter cube per second. So what they have given us is they have given the volumetric flow rate. The gauge pressure at the inlet of the pipe is 500 kilopascal. If I take this section 1, this is section 2. Then PG1 gauge pressure 500 kPa, and while the exit is open to atmosphere, okay, PG2 is the atmospheric pressure, all right, and X component of the force is support is Fx. The support is Fx, the absolute value of X, they want to know Fx. So one thing you can do first, I think you can write in the equation also, but I think you should go for that velocity calculation. That will be helpful. But we know Q is equals to A1 V1. So this is given 0.1. They have given the area. You can see here. So this is given. Let me calculate this first. 200 into 10 power minus 4 into V1. So what will be V1? V1 is 5 meter per second. Anyone can tell me that this area is 200 centimeters square. This is 100 centimeters. I am getting V1 as 5. So what will be V2? Anyone? What will be V2? Just write in the chat box. What will be V2? This is 200 centimeters square. This is 100 centimeters square. V1 is 5. So what will be V2? Half. Right? The area is getting small. So how can the velocity decrease? It should increase now. Double. He is correct. 10 meter per second. Now, apply the momentum equation now. Force in x direction is Fx minus the gauge pressure into the area A1 is equals to final momentum rate in x direction minus initial momentum rate in x direction. Everything they have given, mass flow rate, let's take it common, final velocity minus initial velocity. Final velocity, if you see, the final velocity is V2. Okay, the final velocity is V2. It is in this direction. They have given direction also, x and y. This is positive x, and in the inlet it is in negative x direction. So what I have to do is V final is, I am getting what is the final velocity? I guess this 10, right? V2 is 10. This is 10 plus 5. Why the plus sign came into the picture? Because the x direction is a negative x direction. So minus 5 into minus, that is plus 5. Mass flow rate into, they have given this. I'm getting 15 Fx minus Pg1 A1. Q, I know I have to multiply it by the density into 15. So I guess this is 1.5 into 10 power 3 plus they have given 500 kPa. 500 kPa. And the area is, what is the FX you guys are getting? They asked in kilonewton. So we can eliminate this. What I'm getting is 1.5, 500 by 10 power 4. This to 0, this to 0 gone. 5, 10, 11.5. They have asked in kilonewton. So I have removed this 10 power 3, 10 power 3. This is 10 power minus 4. So this to 0 gone, this to 0 gone. 5 into 2, 10, 1.5, 11.5. How many of you getting this answer? 11.5. चैट बॉक्स में ही लिख दो भाई, किसका आंसर आ रहा है? सबका आंसर आ रहा है ना 11.5? हेलो हेलो
Yeah, you are audible, yeah, but let them put the answer in the chat box.
भाई ये आंसर आ रहा है ना, एक बार टाइप करके बता दो तो फिर okay, I think I should move. I'm not responding, so okay, this is another question of momentum equation. Okay. So guys, you can try this question first. Take 2 minutes and try this one. So this is a more easier question. The same concept, the same thing, everything is same. Just read the question and try to solve. The same concept, same question, nothing different. Everything is same. The equation is same. How to calculate? I have told you how to calculate the velocity, area, blah blah blah. Everything you know. Just you have to do. Just you know the values. Just put in the equation. You will get the answer. Try this question. Okay. I think okay. Air of density 0.5 kg per meter cube enters horizontally into a jet engine at a steady speed of 200 meter per second through an inlet area of 1 meter square. Upon entering the engine, air passes through the combustion chamber and exhaust gas exits the jet engine horizontally at a constant speed of 700 meter per second. The fuel mass flow rate added in the combustion chamber is negligible as compared to air mass flow rate. Also neglect the pressure difference between the inlet air and the exhaust gas. The absolute value of horizontal force in kilonewton. Any of you tried like कुछ किया, मतलब कुछ भी ट्राई किया, क्या किया कुछ? Anybody? Just let me write it. Rho is given 0.5 kg per meter cube. The inlet area, I know this is 1 meter square there. This is a jet engine. Inlet, outlet. This is a jet engine. Air 200 meter per second. This is 700 meter per second. Here it is 1 meter square. I don't know this area, so we all know this. A1 is given 1, V1 is 200, A2, V2, V2 is 700. A2 will be 0.2857. Now, Fx is equals to mass flow rate into velocity final in x direction minus mass flow rate into velocity initial in x direction. Taking mass flow rate common, V final minus V initial. Okay. Okay. In this case, the mass flow rate is not same. This is rho A2 V2 square minus rho A1 V1 square. This is given 0.5, density is given 0.5, area what I got A2 is 0.2857. 0.2857. 57. Velocity is 700 square minus this is 0.5, K1 is given 1, V is 200 square. Do this calculation. This calculation you will get. Let me do this calculation. 0.857 into 700. I think this is 49996. They have asked in kilonewton, so you can write 49.9. This is the answer you guys are going to get. You guys can write it down. Okay. Roshan, hello.
I will continue. Okay. Just
Okay, I will stop sharing. Yeah.
yeah, so screen is visible, right? Anyone?
Yeah, it is.
Okay. Hmm. So how many people are like right now? Any? Hello?
Shubham and
Okay. So please type in the chat. How many of you are seeing this question? Guys? Hello. Only one people are watching this?
yeah, Arnav has not
Yeah, I
responded
think.
from the play. Only one
Okay.
person is there.
Yeah, just solve this question
Okay,
and
okay,
then
okay. No
leave
problem, no
on.
problem.
Yeah.
I'll continue. So see, this is a basic question for from this boundary layer theory, and it is a good conceptual question because on this problem you may find many variations, and by using this you can like later in the slide also you will find questions on this concept only. So what is the approach behind this is that see, it is asking that velocity profile is given, and in this case it is a laminar velocity profile which is given by u by u, which is the capital U is here the maximum free stream velocity, which is shown over here, and the profile is given by this 2 y by del minus y by del whole square, and here del is the boundary layer thickness. So it is asking that what is the volume flow rate through section 2 by 2, okay, and the w is nothing but the width of the section, like width of this boundary layer. So it is asking volume flow rate. So for volume flow rate we know that volume flow rate is given by if we say denoted by q, okay, let me raise this. Anyway, you know this. So if we are saying that, let me write here q is equals to the flow rate that is asking, volume flow rate. So we know that it is nothing but area into velocity, right? And here area can be written as what? W into width into that thickness. So if you are taking like an element from here, let's suppose that at a distance of y, we are taking y from here, y, we are taking an element whose thickness is dy, right? So we can write like, and then through that, if we consider that volume flow rate through that dq, what we can write is dq is nothing but the velocity at that point into area. What is area? Area is nothing but w into dy, right? Now, if we put the value of v, what is v? Here our velocity is given by this u by u function. So from that u by u, here the function is u by capital U, that is equals to twice y by del minus y by del whole square, right? So the value of u, we can say that it is capital U into twice y by del minus y by del whole square, right? So we are putting the value of this velocity, which is given by u here, that is equals to capital U into twice y by del minus y by del whole square. And the this is the width and this is our dy. So it provides, it gives us the equation of this volume flow rate, basically differential volume flow rate, right? So if we integrate this value from 0 to q, let's say, and the value of y is varying from 0 to del, right? So we will get the value of our volume flow rate, right? So this is a basic expression, like you have to from the velocity profile you have to take out the velocity at a particular y distance, which is given by this expression, And when we multiply that with the area, we will get the volume flow rate. And now if we integrate this, we will get the total volume flow rate that is passing through this section to 2. So it's just now it is a basic integration part only. So when you integrate it, what we will get? Here we will get this Q, and this is twice y square by twice del minus this is y cube by thrice del square. This is our limit from 0 to del. So when we solve this, what we get that Q is equals to, this is our U, and here was W into dy. We are integrated, so W comes over here, and the integration part is nothing but y square by del minus y cube by 3 del square, limit 0 to del. So if you put it in this, we will get that it is nothing but U capital W into del minus del by 3, right? We get that del minus del by 3. So we can say that Q is equals to U W into del minus del by 3. So we get the value of UW into twice del by 3, which is nothing but the option number second, right? We get this option 2 into 3 into this del star is by mistake, it won't be there. So it is 2 by 3 into U into W, and it obviously into del. So this is the volume flow rate. So what we have done basically here is we have calculated the differential volume flow rate, and we integrated on the limit from 0 to del. And for the differential volume flow rate, we have multiplied the velocity at particular y into the area, differential area dA, which is equal to W into dy. So one thing that we can consider here is that the velocity profile here given, it is nothing but parabolic profile, right? Where there are 3 basic profile of like laminar velocity profile. There are 3. One is linear, then the next one is this parabolic, and we know there is one more which is known as cubic velocity profile. So like this is the main approach from which you can solve different velocity profile question, but you can also remember the solution basically, or what we can say that there is one more approach to solve this question. You can remember the value for different profile, then directly you can put those values and you will get the answer. Let me tell you this. Where will we? Okay. Next question would be, where were we? We were on this question, right? So there are 3 more velocity profile. One is laminar. We have seen for laminar, like there are 3, which is one first is linear. For linear velocity profile, It is u upon u. It is given by simple eta, and eta it could be a y by del, which is y by del. So this is one linear velocity profile, and the second one is known like it is a parabolic one. So this is given here only 2 eta minus eta square, 2 eta minus eta square. So this is one parabolic profile, and the third one is cubic profile. I should write max here, later it will get confusing. U upon u max. It is 3 by 2 eta minus 1 by 2 eta cube. Okay. So these are the three profile, and in this case we know that the del star, what is del star? Anyone in the comment?
For which one?
No, actually I'm asking anyone is there in the like anyone is watching this, what is known the del star, what do we call this? Are they responding? Displacement thickness, good. So here the displacement thickness is given by, in this case it is given by, wait a minute, del by 2, right? And for this case, parabolic case, the displacement thickness del star, it is given by del by 3. And for the cubic case, it is nothing but 3 del by 8. So like these are the basic profile, laminar velocity profile that is used in this kind of questions. So if you can remember these momentum thicknesses, from directly this value, you can calculate the volume flow rate and things like that. Like how will you calculate that? So we can say that the mass flow rate, which is like what happening is that some mass is entering into this boundary layer, and some is leaving from there. So the less mass, which was like let's suppose it at point 1 it was m1, and now the mass flow rate entering into this section m2 is like from this section 2 is m2. So we can say that m2 will be less than m1, and there are some mass which is leaving from this surface, like this boundary layer. Let's suppose it is m dot leaving. We are saying that m dot leaving. So this m dot leaving is nothing but it is rho, w is our width of the boundary layer, and del star into velocity, okay, which was u. So like in this case, it is asked that volume flow rate through the section. So if we are asking through the section, so we can say that again this value gives the mass. So if we divide it by the density, what we'll get? Mass upon density is nothing but volume flow rate, right? Q dot. So here we will get that W, del star, and U. So we get that the Q star, which is leaving, sorry, Q dot, which is leaving from this boundary layer, is given by this expression also, W into del star into U. So what is the volume flow rate which is flowing through this section, like from this boundary layer? So it is given by Q2 dot. We can say that initial, what was the value of Q dot initial minus which is leaving from the surface, which is leaving from this boundary layer. So earlier, what was the value? It was nothing but W into del, because earlier the length was this whole length was del given. Here it is del. So W into del into U minus, here we know that in the case of parabolic profile, the value of del star is del by 3. So we can say that W into del by 3 into U. So from here we can get the value of this Q, which is leaving like through this, which is flowing through this section 2, is nothing but 2 by 3 U del W. So we from there we can also get the, this is another approach to get this answer. So I'm just saying that if you can remember only these terms, like the momentum thicknesses value, you can directly get this mass flow rate or volume flow rate. You don't need to integrate the whole expression again and again. So it will save your time basically. So moving on to the next question. Okay, and this question is also quite good, I would say, and this is also a basic concept. Let me first you guys try. I'm giving you the expression here, and we will show you how we are getting these expression. Okay, so in this kind of a problem, when there is a time of calculation, you guys need break. Let me if you need break, you can say in the chat. We can resume after some time.
Dinesh and Shubham are saying continue. Hello, Roshan, you there?
Yeah, he is going to solve. Yeah, told me. Roshan, hello.
Roshan, you're mute, huh?
Okay. I'll continue this question again. After that, we can take a break. Like they are also.
Roshan? No.
Am I audible right now? Hello.
Yes, yes.
Okay. Then
Dinesh has given the answer.
Acha, someone has given the answer, right? You got 26.19. Okay, we will see the value, what we are getting. So let me give you the expression first. Try solving like through this, and then we will see the value you have that you got is right or wrong. So this is the expression to get the time. So the expression is like this. Here we get the value of 2. So I would recommend everyone to remember this expression, because it is, I have seen that in past year multiple question has come on this concept only. So if you can remember this expression, it will obviously save a lot of time for you. So by using this, you guys calculate and give me the answer. I will show you how we reach this expression. I've got two answers here. I will tell you the right answer just now. If anyone is also solving, you can put their answers too. Okay, we will solve this question now. Yeah, the answer is actually 18.35, whatever. It is close to 18.23 something. So we will see. Let me first obtain this expression for you guys. So see, actually in this type of question, there is a tank, right? And at the bottom of the tank, it may be that there is a orifice, or there is a hole at the bottom of tank, and through it water is leaking out. or it may be that water is pouring also. So in this type of question, what we do is like we will take that at a height h, okay, from the bottom we are taking an elemental area of like of dh height, and obviously it would be a circular area because it is a cylinder. We are taking the elemental height of dh. So what we will do, like here it is given in the question, the diameter is given, the height is also from h1 to h2 it is decreasing. The value of h1 is 2 and the h2 is 1, and it is decreasing. Diameter of the tank is given d, and the diameter of this hole or orifice is a small d, right? So we can say that how it is asking the time taken in second for water level to come down to height h1, okay? So where did it go? So we can say, like, if the velocity of water flowing through here is v, okay, then we can say that in dt time, okay, the volume flow rate, let's say dq, it is in the dt time. So what is dq? It is nothing but the small area into velocity into dt time. So in dt time, what happens that it has decreased. There is a decrease in this water height, and that decrease is elemental decrease, which is equals to dh. So we can write that it is area, capital area, which is the area of the tank, into dh. So it is the basically volume, elemental volume flow rate, which is taking place in the dt time, right? A into v into dt. And we know that if the water level is h, then the velocity of the orifice, like velocity from the orifice, is given by this expression √2gh. It is a very basic expression. So when we put the value of this velocity in this expression, which is √2gh, right, into dt, and now we are rearranging this expression, area by area here, dh upon √2gh, and here we are left with nothing but dt. When we are integrating this from, let's say, h1 to h2, and here we are increasing from 0 to t. So after integrating, what we are getting is that area by area, capital A by small a, into, here we are keeping the root g term. This is nothing but root h, 1 upon root h, right, into dh, integration of 1 upon root h into dh. Here the value is from just 2 minus h1, and here it is basically integration of dt is nothing but t from 0 to t time. So here we are getting the expression a by a into √2g, and we know that 1 upon root h can be written as h to the power minus half and dh, that is equals to t. So what is this? h2 minus h1. This is h to the power minus half. So integration of h to the power minus half will be nothing but a by a into √2g into h minus 1 by 2 plus 1. So it will be half, and h to the power half, and the power will be coming to the denominator half, which is equals, and the limit is from here h2 and h1, and this is the time t. So from here we can see that expression that we are getting is a by a into √2g, and this half has like gone up, so it is twice. And when we put the value of h1 and h2, we get this √h1 minus √h2, that is nothing equals to t. So this is the expression we are getting, and area can be also written as this diameter upon diameter whole square. Why? Because it is pi d square by 4 basically. So the constant term will cancel out, and we will get this term √2g into h1 minus h2. So this is the expression that you can remember. It will save a lot of time, and it will be used in many of the questions. Like here we can say one thing also, that the time which is required to like empty or maybe fill also the tank is directly proportional to the root h. Here we have got the, after integrating, we got that it is varying on the half power of h. So we can say it is also a relation which can be kept in mind. So when we put the value of the given data in this question, what we get is the diameter is 1 meter and it is 10 centimeters. So we can say 100 centimeter, capital value is 100 centimeter, small d is 10 centimeter. So 100 by 10 into 2, the gravity value is given 10 also. So it is 2 into 10, 20. And from 2, it is coming down to 1. So root 2 minus root 1, which is 1. It will give you the time t. So when we solve this, we get the value 18.29 seconds. So this is the solution for this question. I hope you understand. You guys have any doubt regarding this question?
No, sir.
Okay, so this is the expression that you have to keep in mind. It is very easy, like d by d squared twice upon twice 2 root g, and you have seen the derivation also. So you can relate also, like, okay, where it is coming from. And it will be very helpful if you could remember this. It will save a lot of time because the integration is a little bit lengthy. So we will take a break here, I guess. Isha? Isha, are you there?
Can take the break. Students, do you want to continue the class or do you need a break? I think it's fine. Let's end the session now.
And we will resume in half an hour, right?
Okay.
No,
Students, come back.
they let them answer. Like, what do you want, guys? They are saying okay. Then fine. Then
Okay, then come back after half, or you can stay in the meeting only. Don't leave. Just after half an hour.
you can.
Resume.
Like, yeah.
Fine, fine.
Then that will be fine. Okay, then like what is the time now? It is around 11:40. Sorry, 1:40. So we will continue it at 2:10, hopefully.
2 p.m. Okay, fine,
Okay.
fine. Around
2
2:10, we'll come back.
Okay. 2 p.m.